Hi guys, my name is Melissa, and in today's video we're going to be learning about divisibility with prime factorization. So in this example it says, is 17,640, which is equal to 2 to the power of 3 times 3 to the power of 2 times 5 times 7 to the power of 2 divisible by 28. And so instead of dividing this by 28, which we could do, we can make mistakes since the number is large. So we can consider the prime factorization of both numbers. So the problem already gave us the prime factorization of 17,640. And so for 28, we can do prime factorization to get 2 to the power of 2 times 7. And so for 28, the prime factorization includes 2 twice and 7 once. And so we're going to look for that in the prime factorization of 17,640. And so that does exist since we have 3 2's involved. So that means that 2 2's are involved. And also 1 7 is involved. And so that means that 17,640 is divisible by 28. And even though the question only asked us, is it divisible by 28? What we can do is we can get the answer of dividing the number by 28, and that would be the remaining factors of the prime factorization multiplied. So since we used 2 2's and 7, the remaining ones are going to be 2 times 3 to the power of 2 times 5 times 7, and that's going to be the result when we actually divide. So in problem 113, we're going to solve some practice problems. So it says, circle every number below that is a factor of 890,428, and it gave us the prime factorization. And so to figure out if a number is a factor or not, we're going to do prime factorization of the number and see if we can find that inside the given prime factorization. So first of all, for 4, we have a 2 to the power of 2 involved, so 4 is a factor. But then for 8, we only have 2 to the power of 2, but 8 is 2 to the power of 3, so it has one more 2, so 8 is not a factor. 1 2 and 1 7 is involved, so 14 is a factor. 3 is not involved, so 21 is not a factor. 1 2 and 1 11 is involved, so 22 is a factor. And for 236, since the last 2 digits are divisible by 4, we know that the number is divisible by 4, so we can write that as 4 times 59. And 59 is a prime number, and we have, and 4 can be expressed as 2 times 2, so 236 can be expressed as 2 to the power of 2 times 59, and we have both in the prime factorization of 890,428, so 236 is also a factor. And then for problem 114, it says, circle every number below that has 3 to the power of 3 times 7 to the power of 2 as a factor. And so if we see these 2 in any of the prime factorization, then it is a factor. And so we have 4 3's, so we can definitely say that 3 to the power of 3 can be included, and we also have 7 to the power of 2. So 1,323 is a factor of the first one. There's 7 to the power of 2 and also 3 to the power of 2. So that's a factor of 37,044. And then, although we do have 7 to the power of 2, we only have one 3 involved, so 1,323 is not a factor of this number. And then in the last one, we have 7 to the power of 2 that can be involved, and we also have 3 to the power of 3. So this one also has 1,323 as a factor. For 115, it says, list all of the factors of 480,200, and it gave the prime factorization that are less than 20. And so we have 2 to the power of 3, 5 to the power of 2, and 7 to the power of 4. And so using those numbers, we're going to make numbers that are less than 20. And so first of all, we have 2, like just one of each. So we have 2, 5, and 7 for now. And then we're going to multiply 2 times 5. That's going to give us 10. And so and also, even though it's not given, we always know that 1 and itself is a factor of any number. And so we're also going to include 1. So yeah, and then after that we have before we multiply 2 and 5 together, we can multiply 2 times 2, so 2 to the power of 2, which is 4. So let me just rearrange that. And then we can do 2 to the power of 3, which gives us 8, and then 2 times 5, which gives us 10, and 2 times 7, which gives us 14. So these are going to be the list of all factors of the number that are less than 20. Now we have problem 116. And so it says, given that 42,250, and it gave the prime factorization, and 325 is this prime factorization, what is this division equal to? Again, so we're doing 2 times 5 to the power of 3 times 13 to the power of 2 divided by 5 to the power of 2 times 13. And so essentially we can think of this as, since we have 5 to the power of 3 on top, but then we're dividing it by 5 to the power of 2, if we look at the exponents, 3 is on top and 2 is on bottom, so we're going to think of this as doing 3 minus 2 for the exponents. And so it's going to be 2 times 5, since it's 3 minus 2, so 5 to the power of 1 is 5. And then we have 13 to the power of 2 and 13, so that's basically 13 to the power of 1. So we're going to consider that 2 times 5 times 13, and that gives us 10 times 13, which is 130. Now in problem 117 it says, is this number divisible by this number, why or why not? And so we're going to say that, I know that some of you guys might think it's not divisible because this is 6 to the power of 4, but we only have 6 to the power of 2. But then another way to think of this is that 6 to the power of 2, if you look carefully, it's not completely factorized, right? So it's not prime factorization if you look carefully, because 6 can be expressed as 2 times 3. And so if we rewrite that, that's going to be 2 times 2 times 3 times 3 times 3 times 3 times 3 times 6, and each 6 is going to be 2 times 3. So we're going to multiply 2 times 2 times 3 times 3. And 6 to the power of 4 is going to be 2 times 3 times 2 times 3 multiplied 4 times. So we're basically going to have 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3. And so essentially that is going to give us 2 to the power of 4 times 3 to the power of 7. And this is going to give us 2 to the power of 4 times 3 to the power of 4. And so if you look, we have 2 to the power of 4, and we also have 3 to the power of 4 involved. So actually, it is divisible. So we're going to write yes, divisible. And then we have times table puzzles. And so these are just like the tables we used when we learned multiplication. And so the number in any white box is the product of the shaded numbers above and to the left of the box. And so we'll solve an example just to make sure that we understood the rules correctly. And so we label the factors A, B, C, and D. And then the factor labeled A in the times table is a factor of both 42 and 70. The factor labeled C is a factor of both 42 and 33. And so 42 can be expressed as 2 times 3 times 7. 70 can be expressed as 2 times 5 times 7. And 33 can be expressed as 3 times 11, which is given here. So those are the prime factorizations. And we know that A times C must equal to 42. And so, since 2 and 7 are both factors of 42, but not of 33, we know that 2 times 7 is a factor of A and not C. And so the reason why we say that is because we have 2 times 7 times 2 times 3 times 7, but then 7 is not a factor of 33. So it must not be involved with C, but it should be involved with A horizontally only. And now we can also double check that because 7 is involved in 70, so that means it was horizontal, so it's involved with A. And then next, since 3 is a factor of 42, but not of 70, we know that 3 is a factor of C and not A. And since 42 doesn't have any additional prime factors, we know that A and C do not have any additional prime factors. And so A equals 2 times 7, which is 14, and C equals 3. And then eventually 7t equals 14 times d, and so d is going to be 5, and b times 3 is going to give us 33, and so b is going to equal to 11. And then to find the missing box, we're going to multiply 11 and 5 together to get 55. And so we have timetable puzzles to solve now. And so for problem 118, we're going to label the factors A, B, C, D. And then 14 is 2 times 7, 35 is 5 times 7, and 15 is 5 times 3. And so since 5 is involved in both numbers, we know that D must be involved with 5. And then for these two, we have 7 that's repeated, so we know that A must be involved with 7. And then to check, we know that D times A is 5 times 7, so it's 5 times 7. So we know that D is 5 and A is 7. Now since we know that A is 7, we know that C is 2 based on 14. And then since we know that 15 is B times 5, we know that B is going to be 3. And so we can fill in the missing box by doing 3 times 2, which is 6. For problem 119, we're again going to fill in A, B, C, D, and then do prime factorization of these numbers. So it's going to be 2 times 2 times 3, 2 times 2 times 5, and 3 times 11. So horizontally, we have 2 times 2 that's involved for both. So we know that A is going to be 4. And vertically, we know that 3 is involved for both. So C is going to be 3. And so we know that because we can confirm that because 3 times 4 is 12. And so since A is 4, then that means that D is going to be 5 based on 20, since 5 times 4 must be 20. And then for 3 times B to be 33, we know that B must be 11. And so we can find the missing square by doing 5 times 11, which gives us 55. And then for 120, we're going to fill in A, B, C, D once more. 84 can be expressed as, if we do prime factorization, we can do 2 times 2 times 3 times 7. For 51, we can express that as 3 times 17. And for 68, we can express that as 2 times 2 times 17. So based on this vertical column, 2 times 2 is involved in both. So we know that D is going to be 2 times 2, which is 4. And then horizontally looking at this row, 17 is involved in both. So we know that B is going to be 17. And since 17 times C is 3 times 17, C is going to be 3. And then for 17 times, and to confirm, 17 times 4 is 68, so that's correct. And then to find A, we know that A times 4 is 2 times 2 times 3 times 7. So basically that's 4 times 3 times 7. So we know that A must be 3 times 7, which is 21. And so this missing box is going to be 21 times 3, which is 63. And then for problem 121, we're going to write out A, B, C, D. 65 can be expressed as 5 times 13. 91 is 7 times 13. And 42 is 2 times 3 times 7. Since 13 is involved with both, we know that A is going to be 13. So eventually that tells us that C has to be 5 and D has to be 7, based on 65 and 91. Then we know that 7 times B must be equal to 2 times 3 times 7. So B must be equal to 2 times 3, which is 6. And so this missing square is going to be 6 times 5, which is 30. For problem 122, 165 can be written as 5 times 33. So it's going to be written as 3 times 5 times 11. 88 can be expressed as 2 times 2 times 2 times 11. And 135 can be expressed as 5 times 27. So it's going to be 3 times 3 times 3 times 5. And so looking at this vertical column, we have 3 and 5 both involved, so we know that this must be 15. And based on 165, since these two dark squares multiplied is 3 times 5 times 11, or 15 times 11, this would have to be 11. And then based on that information, we know that this box times 11 is 2 times 2 times 2 times 11. So this box must be 2 times 2 times 2, which is 8. And then we know that 15 times this box must equal to 135. And 15 is 3 times 5. So the 3 times 3 must be responsible for that box. So this box would be 9. And then, so we can figure out this box by multiplying 9 and 8, which is going to be 72. Now we have problem 123. And so 40 can be expressed as 2 times 2 times 2 times 5. 63 can be expressed as 3 times 3 times 7, and 105 can be expressed as 3 times 5 times 7. And so 5 is involved in both, so this column is going to be 5. Then that means that this box is going to be 2 times 2 times 2, which is 8. And that tells us that this box must be 3 times 7, which is 21. And so since that was 3 times 7, we know that this box must be 3. And so we can find out this box by multiplying 8 and 3, which gives us 24. And I know that the pace might be a little fast today, but that's because we have a lot of problems to cover. And so if you guys need any clarification or need to go back to another problem, or just simply need more time to solve some problems yourselves, always just feel free to pause the video and then come back when you're ready. So we're on the last page now, and we have 6 more timetable puzzles to solve. And so for problem 124, 54 can be expressed as 2 times 3 times 3 times 3. And 48 is 2 times 2 times 2 times 2 times 3. And 63 is 3 times 3 times 7. Now we have a 3 times 3 repeated in this column. So this box must be 3 times 3, which is 9. And in this row we have 2 times 3 repeated. So 2 times 3, which is 6, must go in there. Just to confirm, 6 times 9 is 54. And so since 6 is 2 times 3, this box must be the remaining 2 times 2 times 2, which is 8. And 8 times 6 is 48. And so 9 times this box must be 63. And 9 is 3 times 3. So this box must be responsible for the 7. And so this box can be solved by multiplying 7 and 8, which gives us 56. And then for problem 125, 144 can be expressed as so it can be expressed as 9 times 16 so that's going to be 2 times 2 times 2 times 2 times 3 times 3. And then for 200, we can express 200 as 2 times 2 times 2 times 5 times 5. And then for 270, we can express that as 2 times 3 times 3 times 3 times 5. And so in this column, we're going to look for ones that are repeated. So 1, 2 is repeated, 1 and 2 3s are repeated. And so this box is going to be 2 times 3 times 3, which is 18. And so this box is going to be the remaining ones. So that's going to be 2 times 2 times 2, which is 8. And this box is going to be the remaining ones over here, which is 3 times 5, so 15. And since 8 is 2 times 2 times 2, we take this out. And so this box is going to be responsible for 5 times 5, which is 25. So we can figure out this box by multiplying 8 and 25, which gives us, we can figure this out by multiplying 15 and 25. And so that's going to give us 375. Now we'll look at 126. So now we have one more column now. So we have A, B, C, D, and E now. But we're still going to follow the same pattern as what we've been doing so far. So 60 can be expressed as 2 times 3 times 5. 32 can be expressed as 2 times 2 times 2 times 2 times 2. 72 can be expressed as 2 times 2 times 2 times 3 times 3. And 63 can be expressed as 3 times 3 times 7. And so for this column, we know that 2 3s have been repeated, and so that's going to go in here. So 2 times 2 times 2 is going to be 8. So 8 goes in there. And since we have 8, we know that this square times 8 is going to give us 32. And 8 is 2 times 2 times 2. And so the remaining 2 times 2 is going to go in this square, so that's going to be 4. And then we know that these two multiplied gives us 60, and 4 is 2 times 2. So the remaining 3 times 5 is going to go in this square, so that's going to be 15. And then we know that this 8 times this square gives us 72, and 8 is 2 times 2 times 2, so the remaining 3 times 3 is going to go in this square, so that's going to be 9. And then we know that 9 times this square must equal to 63, and 9 is 3 times 3, so the remaining 7 has to go in this square. And so we can figure out these two boxes by doing 7 times 4, which is 28, and 15 times 9, which is 135. Now we have problem 127. Again, doing the same thing. 88 can be expressed as 2 times 2 times 2 times 11. 68 is expressed as 2 times 2 times 17. 175 can be expressed as 5 times 5 times 7. And 119 is 7 times 17. So in this column, 17 is multiplied for both numbers. So this is going to be 17. And this box times this box gives us 17 times 7. So this box would have to be 7. And then we know that this box times this box has to give us 175. And so the remaining 5 times 5, excluding the 7, is going to be in this box. So this box is going to be 5 times 5, which is 25. And then we have this number times this box must be equal to 68. So the remaining 2 times 2, which is 4, is going to go in this box. And so we know that 4 times this box must be equal to 88, and 4 is 2 times 2. And so the remaining 2 times 11, which is 22, is going to go in this box. And so to figure out these two squares, we're going to do 4 times 25, which is 100, and 22 times 7, which is 154. And so we're on problem 128. And so 56 can be expressed as 2 times 2 times 2 times 7. 36 is 2 times 2 times 3 times 3. 98 is 2 times 7 times 7. And 90 can be expressed as 2 times 3 times 3 times 5. And so first starting with this row, since we have two repeated ones. Well, sorry, we're going to start with this column since we have two repeated and full product squares. We're going to look for ones that are repeated, and the ones that are going to be repeated are 2 times 2. And so that's going to go in this square. So 2 times 2 is 4. And so we know that this square times this square must equal to 56, and 4 is 2 times 2. So the remaining 2 times 7 is going to go in this square. So that's going to be 2 times 7, which is 14. Then this 14 times this square must be equal to 98, and 14 is 2 times 7. And so the remaining 7 is going to go in this box. So we have a 7 there. And then we know that 4 times this square must equal to 36, and 4 is 2 times 2. And so 3 times 3 is going to go in this box, and that is going to be 9. Then we know that 9 times this square must equal to 90. And 9 is 3 times 3, so the remaining 2 times 5, which is 10, is going to go in this box. And so 7 times 9 is going to go in here, 63, and 10 times 14, which is going to be 140, is going to go in this box. And then we're on to our last question of the video. And so we have 294. So 294 is going to be expressed as 3 times 98, and so that can be expressed as 4 times 20. Sorry, so instead of 4, that can be expressed as 2 times 49. 49 is 7 times 7, so 294 can be expressed as 2 times 3 times 7 times 7. 210 can be expressed as 21 times 10, so 3 times 10 and 2 times 5, so 2 times 3 times 5 times 7. 88 can be expressed as 2 times 2 times 2 times 11, and 112 can be expressed as 2 times 2 times 2 times 2 times 7. And so in this column, the ones that are repeated are 1, 2, and 2, 1, 2, and 1, 7. So that's going to be 7 times 2, which is 14 in this square. And we know that these two squares multiplied would be 294, and 14 is going to be 2 times 7. So the remaining 3 times 7, which is 21, is going to go in this square. Then we know that 21 times this square must equal to 210, and 21 is 7 times 3. So the remaining 2 times 5, which is 10, is going to go in this square. And we know that 14 times this square is going to be equal to 112. And 14 is already 2 times 7. So the remaining 2 times 2 times 2, which is 8, is going to go in this square. And then we know that 8 times 88 must equal, 8 times this square must equal to 88. And 8 is already 2 times 2 times 2, so the remaining 11 is going to go in this square. And so to figure out these two squares, we're going to do 21 times 11, which gives us 231. And for this square, it's 8 times 10, which is 80. And yeah, that was the end of our video and lesson today. And I'll see you guys all in the next video. Bye!